Hello students, this is Dr. Munir Umar with CS 371 Data Communication and Networks. As per our KCMS activities and our defined course outlines, today we have lecture number 28. In this lecture, we will study about the transport layer protocols, which are UDP, User Datagram Protocol, and TCP, Transmission Control Protocol. These are the outlines for our today's lecture. First, we will study about the transport layer, then port number, then we will have UDP, and at the end we will have TCP. Under UDP and TCP we have many topics which will be covered in this lecture. Okay, let's start with the transport layer. When we talk about the communication, we say that it is the exchange of data between two nodes or between two hosts. But in fact, the real communication takes place between two processes. At a moment, on one system, there might be several processes running. By process, we mean that the applications or the softwares on systems which we execute. So, the real communication is actually the process to process communication, and these processes run on the hosts. The transport layer is responsible for process to process delivery or data delivery. The delivery of a packet, actually the transport layer makes some packets from the data message, and these packets are transmitted from one process to another. Two processes communicate in a client-server relationship. Actually, two systems, when they communicate, one sends data and the other one receives that data, or one sends a request and the other responds to that request. In simple words, we can say that the transport layer is responsible for process to process delivery. Earlier, we have studied about the data link layer and network layer. So the data link layer is responsible for delivery of frames between two neighboring nodes or a link. Now, if you look into this diagram, here we have some nodes interconnected with each other. Here we have connectivity among these nodes. All these are neighbor of each other. So data link is actually responsible for data delivery, or this link are from one hop to another hop. This is called node to node delivery. The network layer is responsible for delivery of datagram between two hosts. So here we have the source host, and on the other side we have destination host. In between we have some routers or some hops. So the network layer is actually responsible for this entire path, or we can say that it is responsible for the delivery of datagram from source to the destination node. This is called host to host delivery. Now, if we look into the transport layer, we say that there would be some processes or several processes on a system. So among these processes, one process may send data to another process, on the destination host. So this responsibility is taken by the transport layer. Transport layer is responsible for process to process delivery. Transport layer creates packets for this purpose. It should be clear by now that the IP addresses and port numbers play different roles in selecting the final destination of data. IP addresses are used for hosts while port numbers are used for processes on these hosts. Now, here we have different processes on a daytime client. Similarly, on daytime server, we have some processes. Among these processes, one process wants to send some data to another process on the daytime server. Its port number is 52,000. Actually, this number identifies this process. Similarly, this 13 identifies this process. So, with the help of these two numbers, we can identify these two processes, and these two processes are attached in the transport layer while creating the header that is concatenated with the data. The IP addresses and port numbers both are used for identification. The IP header keeps the source and destination IP addresses. These are used to identify the systems or the hosts in a network. So one would be the source host and the other would be the destination host. While the transport layer uses the port numbers to identify the source process and the destination process on these source and destination hosts. Then we have IANA. Some people pronounce it as IANA. It stands for Internet Assigned Number Authority. It has divided the port numbers into three ranges. Actually, one port number uses, or the size of port is 16 bits or 2 bytes. So the possible values for 2 bytes or 16 bits are up to 65,535. So we have actually this range for the port numbers. Any process that is connected in the network and want to send or receive some data must have a port number, and that port number must lie between 0 to 65,535. These port numbers are divided into three ranges: the well-known, registered, and dynamic. The well-known ports are ranging from 0 to 1023. These are assigned and controlled by IANA. These are well-known ports and these are occupied by well-known applications or processes, and we use those applications in common in most of the operating systems and network. Then we have registered ports. These ports are ranging from 1024 to 49,151, and these are not assigned or controlled by IANA. They can only be registered with IANA to prevent duplication. We can use these port numbers without any registration or without any application to IANA, but it is preferred to get these port numbers registered with IANA so that we may avoid any sort of duplication. Then we have dynamic ports. These ports are ranging from 49,152 to 65,535. These are neither controlled by the IANA nor registered by any body. They can be used by any process. Then we have socket addresses. Process to process delivery needs two identifiers, the IP address and the port number. So at each connection, we must have these two numbers. The combination of an IP address and a port number is called as socket address. The client socket address defines the client process uniquely, just as the server socket address defines the server process uniquely. The transport layer protocol needs a pair of socket addresses. So actually we use this pair for identifying the client as well as the process on the client. Then we have error control. We have already studied this topic in the data link layer. Data link layer is responsible for error detection or error control from hop to hop, from one node to another. This one is done by data link layer, while the transport layer is responsible for the error control over the entire connection or from one process to the another process. So in the data link, error is checked in these paths from one hop to another hop, while the error is not checked on data link, that is the upper layer, that is network and transport layer. So these are done by the transport layer. So if we look into the TCP IP suite, the transport layer has TCP, UDP. These two protocols are well known and mostly used by different routing protocols or for different communication purposes. We have also another protocol, that is HTTP. So we will study about the TCP and UDP in the coming slides. TCP and UDP. When an application sends a message down the protocol stack, it selects whether TCP or UDP should be used for the transmission. We have a TCP IP suite, and on application layer we might have different processes or protocols running. So these protocols select either TCP or UDP at the transport layer. For example, HTTP must select from these two at the transport layer. So HTTP usually selects TCP, it must select TCP, and after that move towards the network layer. We may have some protocols like SNMP, which selects UDP and then move towards the network, data link and physical layer for the transmission. User Datagram Protocol, UDP. UDP is a simple protocol and it takes the responsibility of process to process communication without taking any additional responsibility that may give some services of IP. So the definition of UDP is the user datagram protocol is called a connectionless, unreliable transport protocol. It does not add anything to the services of IP except to provide the process to process communication instead of host-to-host communication. Actually, this host-to-host communication is covered by the network layer, and the UDP, which lies on the transport layer, gives only process-to-process communication, or takes the responsibility of process-to-process communication only. This one protocol is connectionless and unreliable because it does not give any additional procedure or any additional sort of responsibility at the transport layer. The first thing about UDP is that it is connectionless protocol, or we can say that UDP has no connection establishment. Two hosts or client server can communicate in two ways. The first one is connectionless and the second one is connection oriented. In case of connectionless communication, the client and server, are the two communicating hosts, send and receive their data directly without having any proper handshake or connection establishment. So here the client sends data directly to the server, and it doesn't care about the delivery of data, as it does not get any sort of response for the received packet from the server. So this type of transmission is known as connectionless data transmission, and this is done by UDP. In case of TCP, we have a proper procedure for connection establishment, having a proper handshake, and also the server or the receiving end sends some acknowledgement packets to ensure to let the sender know that the transmitted packets are received properly. Since the UDP is connectionless, therefore the time on connection establishment is not consumed and it has lower delay during the data transmission, because there is no additional mechanism for the connection establishment. Therefore, it is a simple protocol. No connection state is needed at sender and receiver side. It has a small segment header because we don't need any additional information for acknowledgements or for connection establishment. The UDP has no congestion control. As we say that UDP is a simple protocol and it has only one responsibility, that is to ensure the process to process data communication. So it blasts all the data in one direction from the sender to receiver without knowing the status of the sent packets. So it doesn't care about any sort of congestion on the route. It is often used for streaming multimedia apps because UDP is loss tolerant and rate sensitive. UDP can be used on different protocols, for example, DNS and SNMP. This is the format of UDP datagram. First, data is received from the upper layer, the session layer, and then one header is added at the transport layer. So if we are using UDP, then this header must include these four components. The first one is source port number. We have already studied about port numbers, so its size is 16-bit. Then we have destination port number, that is also of 16 bits. The total length identifies the size of header plus data, and the checksum. Checksum is an optional part in UDP, and this is used for error detection. So here we have the source port, which identify the originating application. The destination port identifies the destination application, which is on the destination host. Length of UDP datagram, that is UDP header plus data, and then the checksum of IP pseudo header, UDP header, and data, which is used for error detection. Next is TCP, the Transmission Control Protocol.